Okay, everybody, I would like to take a look at this little segment of simplifying square roots prior to your work with section 5-3. There's going to be some portions in 5-3 in the homework where not having this knowledge armed and at the ready can cause a little bit of problems with a couple of the homework problems. It won't cause really big problems in the big picture when it comes to tests and things like that. At least not a whole heck of a lot, but trust me, you're going to want to pay attention to a couple of these ones here. So, let me just put it to you this way, and I've gone over this before. There are three types of square roots that many students experience in Algebra 2. One kind of square root that many students like are ones like number 7 and ones like number 8. Why are square roots like those two very, very easy and very, very happy for students to try and simplify? Students love doing these ones. Here's why. Because it belongs to this group that you see right here of a list of perfect squares. You see that 64 belongs to that group and 121 belongs to that group. And we know that 64 is 8 squared, so we know the square root of 64, you are 8. And the square root of 121, that would be 11 squared, so we know the square root of 121 would be 11. So these are some square roots that we would be very, very happy to try to simplify. There's actually another kind of square root that actually, believe it or not, you are very, very happy to simplify. Okay, and that would be something like this. Let me put it here in green. The square root of 7, or say the square root of 15, or let me try and think of an even number like the square root of, say, 22. These ones here you're very happy to simplify. The reason why is because this is the exact answer that you can possibly give somebody. One of the things that we focus a lot on is precision, and we don't want to lose any precision when it comes to writing equivalent statements. Remember, an equal sign is a statement of equivalency. I am stating that the square root of 64 is exactly identical to 8. The same with the square root of 121. It's exactly the same as 11. And when you start to try to give somebody an equivalent statement that means the exact same thing as the square root of 7, it's absolutely impossible to do it, because if you take the square root of 7, you end up with a decimal that inevitably you have to round, which once again now you have lost precision. The same thing with the square root of 22. You lose that precision. Okay, so when a teacher asks you to simplify those types of answers, ones that look like this, you are very, very happy. The reason why is because you're actually looking at the most simplified answer possible. You don't have to do anything with them. Okay, so those are some square roots that people like very, 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 very much. Here are the ones that students do not like. Students do not like these guys here. Okay, and so what I'd like to do today is show you how you can make these very, very doable. The trick on doing these very, 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 very well is having a good idea about this list of perfect squares. Okay? Let me put it to you this way. Here's an analogy. No math teacher on this planet would ever let you leave an answer or a fraction like that, would they? They'd never let you leave it as 6/8. They would like you to write it in simplest form, and the simplest way to write 6/8 would be 3/4, right? Smallest numbers possible to represent an equivalency, okay? Well, with square roots, it's absolutely no different. Can I rewrite this square root with an equivalent statement here? And here's an important property. Here's what we're going to do. Here's an important property of square roots. If I can take a product of two things that multiply together to give me a certain product, I am allowed to take the square root of each one individually and multiply those together. Okay? For example, if I look at the square root of 120, this right here, me breaking down 120 into, say, I don't know, let's do 12 times 10. No harm, no foul, because last time I checked, 12 times 10 would give you 120, right? No harm, no foul. I could call this 120 times 1. Okay, and this would be mathematically equivalent of me taking the square root of 120 times this, oops, not an equal sign, but times the square root of 1, or the square root of 12 times the square root of 10. Now, we don't want to really use these ones, and the reason why is because, once again, we lose precision. The square root of 12 would be a decimal that goes on forever and has no pattern to it. Remember, we call those irrational numbers. However, what if I were to use a list of these perfect squares? Okay, and break that one down and use perfect squares to simplify that square root of 120. Can I break this apart into two numbers, or one of those numbers actually is a perfect square? So what number on that list do you think you can use that would help us simplify this square root? Let's find out. Well, what about 4? Is 4 divisible, or 120 divisible by 4? I think it is, right? And couldn't we write that as 4 times 30, right? So if I write that down as 4 times 30, that would allow me to write this down as the square root of 4 times the square root of 30, right? And then I can take the square root of 4, which would give us 2, and then we'd have the square root of 30 left over. And this actually is the most simplified expression, and we've lost no precision here. It's exactly equivalent, okay? And that's what we're up against here. Okay, can I show you a couple of tricks that I used up my sleeve that I was doing up in my head to help me with this here? First, here's a nice little trick that helps. Let me get rid of this highlight here, this 4, and erase that 30. Okay, here's one thing I know for a fact. I'm trying to factor 120, and when you're trying to break down a number into factors, isn't it true that the two numbers that you're going to have to always be smaller or the same as that number right there? So if I'm looking at a number like 120, I can automatically rule out any number that's higher than 120. So that rules out all these guys. Okay. Secondly, the smallest integer that would make even remote sense of to try to factor this into would be 2. So essentially what I also do at that 120 is I take that 120 and I cut it in half. 120 cut in half, I can do that in my head, that's 60. So any number that's higher than 60 is also off my list. So now I'm looking at these 1, 2, 3, 4, 5, 6 numbers right here. The common mistake that students make when it comes to trying to simplify using square roots, and you've probably seen this work before, is they try to start from here and then they start to work their way up, and they look at this and they say, ooh, 4 times 30, and then they're good to go, and then they go from there. Okay? That's a bad way to go. Instead, what you should be doing is actually starting with the highest number that's still left and work your way down the list until you find one. You want the largest perfect square possible. The reason why you want the largest perfect square possible, let me go ahead and give you another example here. How about if we did, let's see here, 12/18, and I wanted you to reduce that fraction. You wouldn't reduce this fraction by saying to yourself, ooh, I could divide both these by 2, and then I could write 6/9. Do you see why I wouldn't call that a correct simplified fraction? Reason why is because you didn't use the largest number possible. The largest number possible that would be a common factor between 12 and 18 would be 6. So you divide both of them by 6, and then you'd get 2/3. We are essentially trying to do the same thing here. I'm looking for the largest perfect square that would go into that number there. So let's repeat this process, and let's look at question number 2. So the square root of 96. Definitely not on this list of perfect squares, but maybe there is a perfect square that can be used here. So here's my cheat codes here once again. 96. I'm going to break it down to two numbers. One of these numbers needs to be a perfect square, right? Can't be any higher than 96, so that rules out all you guys. Do you know what roughly half of 96 would be? Well, half of 96, what would that be? 48? I believe, right? So I can rule out any number that's higher than 48, so that rules out you guys right there too. So 36, is there any chance at 36, if I count by 36s, will I hit 96? I don't think I will, so I can get rid of that guy. Count by 25s? No. What about 16? Is it possible? Is it possible? Here's how you can check. If you have any shred of doubt whatsoever, take that number and then just divide it by that perfect square. And now we've got our answer. It works. It's 16 times 6. Okay, so here's what we're going to do. We're going to break that down now into 16 times 6. And now that allows us to write this now as the square root of 16 times the square root of 6. What's the square root of 16? It's 4, and then we have the square root of 6 left over. Okay? Let's do this with a couple more problems here, and I'll show you one big mistake that a lot of students make here. Let me show you that common problem that I see all too often with students when it comes to the work that needs to be done here. So square root 54. Okay, once again, what numbers can we rule out here? Any number that's higher than 54. That rules out all you guys here. Nope. And then cut 54 in half. 54 cut in half, wouldn't that be, what, 27? Right? So, nope, can't be you, can't be you. Definitely not 25. 16, count by 16s. Like I said, you got any doubt whatsoever, give it a try. What was it? 54, right? Divide it by 16. You probably already know the answer. But what does this mean? That means that we do not have the right number. We go on to the next one. 54 divided by 9. And then there it is. It's 6. Now that mistake I was talking about here. This is the mistake that I see so many students make. They see that perfect square, and here's what they write. See what's wrong with that picture? They forgot to square root. Okay? Make sure you square root that number. So that's the biggest mistake I see from most students. The biggest forehead slapper when I have to hand that back to students and they make the mistake. So that shouldn't be 9 square roots of 6. That should be 3 square roots of 6. Okay? So rapid fire here, looking at some of these other problems here. Taking a look at number 4, 84. Biggest perfect square that goes into 84. Let's see here. What should we get there? How about 4 times 21? Here's another reason. Here's another way to check to make sure you found the biggest one. If you're ever unsure and you get a really low number like 4, you look at that other factor of 21 and you go back to this list. And is there any other number on this list that would go into 21 that's a perfect square? No. If you can't find another perfect square that goes into 21, or any other number after you found the other perfect square, then you did find the biggest perfect square. So then we can take the square root of each one of those, and then there would be our answer right there, 2 square roots of 21. 32 is my favorite. This is my favorite square root because this is the one where students will try and do this to me, is that they will look at this problem, and I can clearly tell when students are starting from the bottom and starting with the lowest number and working their way up, because then they end up trying to do this to me. They say, ooh, 4 times 8, and then they try and tell me the answer is 2 square roots of 8. And I have to mark it wrong. Do you see why? And it goes back to that move I just said right here. See how 21, there were no perfect squares that go into 21 from that list, but look at 8. Is there a perfect square from this list that will go into 8? Yes, there is. It's a second 4. So we actually have the wrong number here. That's why we start from the top, the highest number possible. So 32, what happens when you cut 32 in half? What do you get? Oh, wait a minute. You get exactly 16, don't you? And 16 is from that list of perfect squares. So 16 times 2. Take the square root of each one of those. Oops, looks like I forgot to put my square root on there. I probably fix it right there, don't I? So let me put that square root there, right where it should be. Sorry about that. Okay, we're starting to get the hang of this a little bit. Yeah, 60. Perfect square goes into 60. I don't know. I think 4 is probably the best way we can go. If we do 4, we end up with 15. Any other numbers? Nope, I don't think so. So then we can work that problem out. Boom, there we go, 2 square roots of 15. 117, you might have to kind of pick and choose that one a little bit there, but 9. 9 works. 13, no other perfect squares go into that one. There we go. So 3 square roots of 13. 144, hey, wait a minute, you're on that list. So square root of 12. Okay? Now, I'm not going to finish this side, but on the other side of this worksheet, we're going to talk about some important stuff here, okay, which will lead into 5-3 and some very important work with 5-3 and the rest of the work that you're going to be doing for the rest of the